Excuse me, sorry. I was feeling tasty a little bit. Look, subtrana here. You FaceTime. I'm trying to apologize. I was feeling tasty a little bit because before I get started doing your questions, I don't drink some water. So look, just like I said always, right? Since this shot, this question count from, all the questions most of the time come from New Orleans because I don't know. In I was meant to say Mississippi and Alabama for the most time, but this one today, it came from another place I didn't even expect. See, this question come from Tampa, Florida. So Florida. So this question come from there, and also the similar question also come from a student from KwaZulu-Natal. They always send me a question, student from South Africa, KwaZulu-Natal. So let's get started without further ado. Let's go into it. Okay, look. So let's say here integrate. This neck here is called integral. Integral. So integral of that. So we're gonna have to expand it. But before we get started, look. You might be new to this program, right? So what you do, come here, show me some love, right? Subscribe here so that you can get the notification and they help me to reach 100,000 subscribers. So now what we're gonna do is easy here. So we're gonna say, you can simply say, we're gonna take that, multiply by the next one. This multiply because there's a bracket for both, multiply. So this is gonna be integral. X cubed times 1 is gonna be x cubed. Now plus. Now x cubed times 1 is going to be x cubed over x squared. Plus, look, this is x squared, and then you square it, means this and this is going to cancel. So we'll be left with x. You see what I'm saying? Means you'll be left with x there. It's like somebody give you, somebody give you square root of 4. What does that mean? This 4 is like a 2 square root, meaning this and this is going to cancel. So we're left with only 2. Same with that. Means square root of x squared means this and that cancel. So we're left with x. Okay. So now we go there. Okay. So x cubed times 1 because we multiplied by the top. It's going to be x cubed over. So this and that cancel. We're left with only x and then dx. So what we do now, we can simply simplify that one. So we say, okay, integral. This is x cubed. And the plus, look. 2x go and 2 you're going to remove it, means you'll be left only 1x plus 1x and 1x go, means you'll be left with 2x, the x squared dx. So now let me show you the rules of the power rule of integration. If somebody give you integral of x power n dx, this you call power because there's a power here, right? Power n. So what you do is say this is equal to take exactly x power n and then plus 1 and then you over exactly all of this stuff on the denominator. What does that mean? For example, if somebody give you x power 4 dx, what does that mean? This meaning take exactly this one, which is x power 4 plus 1 over the same thing, now that number divided the denominator. So this is going to give us x 4 plus 1 equal to 5 over 5. Oh, so for that case now we're going to go and finish up that question right there. You see? So then we're going to say this, let me say, I can separate face because integral the first one, integral the second one, integral the third. So say integral of x cubed with a dx plus integral of x with a dx plus the last one, integral of x squared and dx. So that's our power rule. Now let's say finish up. So it's going to be with plus 1 because now we integrate. So when you integrate x cubed, means it's going to be x. Take 3 plus 1 equal to 4 over 4 plus this is 4, sorry, and a plus. Now this is like power 1. If somebody say x, means x power 1. So apply power rule of integration. This could be x 1 plus 1 equal 2 over 2 plus this is x squared, right? So plus 1 is going to be x cubed over 3. That's all we finish. So we come in an option, we want to look if we got the answer. X power 4 over 4, x squared over we can rearrange because the answer is this one, but let's rearrange. But you must plus your c. You know why you plus your c? Because there is no limit. If there's a limit, no, you're gonna have to substitute the limit, put it in, which I'm gonna show you more example like the next question. So now we can rearrange. It's always good to start with the 4 3 2. So then this, if I have to rearrange, I say okay, so this is equal to x4 over 4 and then plus, let's go for 3 1 x power 3. Because we start with the higher coefficients and then we go to the smallest one, square plus c. So which is the option number 3. Now let's go to the second question, which I'm going to show you now how to substitute the limit. Very easy how to substitute the limit. Okay, now let's go and substitute these limits here quick for the next question, question number 2. So let's say integrate, but now they give you e. My God, they give us e. What is that? Now what I'm going to do is easy. Okay, listen to me. If somebody give you integral, let's say e of a function, and let's say dx. So what you do, you say this is the same as, say 1 over, these are rules, right? You say 1 over, differentiate this function here. So when you differentiate f of x means like f prime, you get f prime because it's f. So you differentiate, and then you write your e exactly the way how it is, and with plus constant or with plus constant, because we don't have a limit. But if you have a limit like the next one, I'll show you how we can do. Meaning, if this is the case, it's going to be 0 to 1. You understand that? For example, shows my apology. For example, so what does that mean? For example, if somebody give you integral of, let's say, e x squared, let's say x squared, they say differentiate. So what you do, we say we want to say this, and we say 1 over differentiate what is there. When you differentiate x squared, it's going to give you 2x. And then you write exactly what we have here, which is e x squared. That's all. That's how you differentiate the exponential integral. So there's the rules. The first question was a power rule. That's why we have to use that rule. But this is exponential integration. Now, let's go to the actual question now. So what we're going to do here, I'm going to first and foremost, you see this 18? 18 is just a constant. So we take it behind. So then we're going to say 18 is just a number, And then now we're going to integrate because it's a constant number. So here is going to be 0 to 1. And then we write our e and then 3x plus 1 dx. So what we're going to do, we're going to do the same game like how I just said just now. So this is going to be 1 over. But for now, it's not a 1. We have 18. So we're going to say 18 over 18 over. Now we're going to differentiate this 3x plus 1. So when you differentiate 3x plus 1, you know this is like power 1 means when you differentiate 3x, it's going to give you 3. When you differentiate constant number is 0. So just a 3 here. So our final, when you differentiate, get the answer right here. You're going to get 3. You have to know how to derivate. These are basic stuff, okay? So now you write exactly, and they say 3x plus 1. But we're not going to plus c for this case because we have our limit 0 to 1. So the next thing, put your limit in. But before, negative 18 over 3 equal to negative 6. So this is going to give us negative 6 here. Okay, simply write negative 6. I missed the orange color. That's from to the negative 6 orange color. And then we're going to say equal, negative 6. And then because, okay, let me write here, excuse me. Negative 6, right? Negative 6, and then this and this negative 6. So I can write my bigger bracket. Okay. Now I have to put upper limit minus lower limit. What that means e just e. In the position of x, I must substitute first the upper limit, which is 1. Anyway, there's x, so it's going to be e. Now see 3 times this number. 3 times 1 equal to 3 plus 1 equal to 4 because it's going to be low. 3 times 1 is 3, but we must plus 1 is going to be equal to 4. And then we're done with the upper limit. Now we're going to substitute lower limit everywhere there's an x. So we're going to say minus e. This 0 is going to come there. So when you plug a 0 here, it's going to be 3 times 0 equal to 0 plus 1 equal to 1. It's going to be e power 1. So what we can do now, we can simply plug in the calculator. Here we have a negative, right? But do not forget your negative. Where does negative come from? There's no negative there, man. No negative, Femi, just equal. Sorry. There's no negative. This is equal sign. I'm sorry. It's equal sign. Apologize. I need to look very, very careful. So now what we can do here, we can simply plug in the calculator. Let me show you if we can plug in the calculator and finish. So now we're going to come here and plug a calculator and put the calculator here. And let's clean my calculator first. Okay, clean a calculator and they say E6, just 6. And then bracket E E, so I can just shift and then E somewhere here. Yes, E power 4, and then we come here next. Next, come on, next, and then we say minus, shift, E, power 1. Come here, close, and then get us. So 31127. So if you approximate, that's going to be 311279, right? That's our answer. 311. Okay. When you plug this in the calculator, it's going to give you 311. 3 is going to give you 311 point what? Let me again 279. So we come here in option means they only did like they say here in rounded to an integer, but integers like this, like you don't need this ratio stuff, they just need this. But this number here is less than 5, so it's not going to have any effect. So just 311. But if this number was say, let's say 9, so it's going to change this, going to be 312. But for this case, it's not more than 5 or 5, so it's going to be what answer. Okay, for that case, that's going to be now. Now that's going to be your answer. But let me tell you something. Okay, so now if there's something here, please, man, like I say, you know, I love for you. Come here, show me some love, subscribe. You know, so I know they student now from Alabama and Tennessee. They'll be like, oh, we're trying to thanks a lot of, you know, for what you're doing. Come on, same equation. If you got this similar question type, send to me, because this is just a basic integration. You can send to me anytime. Okay, don't apply to me, even though I look like I'm unapologetic, but don't apply to me. Same equation. Thanks a lot for time. And you know, subscribe, share this video. Don't not keep it to yourself, because it's not good. Just like the how you name, share to other people. So for that being said, I want to say thanks a lot for your time, and